Okay, a carbon monoxide molecule has 3 bonds between the carbon atom and the oxygen atom. Which features are present in a CO molecule? And then your 3 options there. Okay, we'll go through them one by one. Best way we can do this really is to draw out the structure. Now, this isn't one of the examples in your textbook, unfortunately, but we'll do it now and it'll be one to remember for sure. Right, I'm going to start by just drawing out simple structures for carbon and oxygen. Okay, so let's do the electrons slightly different color. We know that our carbon has 4 electrons in its outer shell, and we know that our oxygen has 6 electrons in the outer shell. Now I'm going to put these 6 electrons in a specific way. Okay, do 1, 2, 3, 4, 5, 6. And the reason I'm doing that is because we should know that electrons will first fill orbitals singly and then they will start to pair up, okay? But they like being in pairs, but first you need to fill single orbitals, okay? That means that our oxygen at the moment has 2 lone pairs, right? And these kind of single electrons are going to want to pair up. Now, it doesn't really matter what I show this pairing up with, but let's say that these 2 guys pair up, okay? So they've got a shared pair of electrons. That will be a covalent bond. And then these 2 guys will pair up. That's a shared pair of electrons. So now we've got 2 covalent bonds, or 2 single covalent bonds, sigma and a pi. That doesn't really matter. But anyway, what we got so far is something that looks like this. Okay, and then we've got 2 electrons there, and we've got 4 electrons there, 2 lone pairs of electrons on the oxygen. Okay, so if we count the electrons surrounding the oxygen, we've got 2, 4, 6, 8. So essentially that oxygen is happy, okay, because it's got its full outer shell. And let's look at the carbon now. We've got 2, 4, 6. So this carbon at the moment in this situation is what we call electron deficient. So what happens is that basically is that you've got these 2 electrons. We just take these. Okay, and I draw an arrow there, and that's making our 3rd bond. And our 3rd bond, because both electrons are being donated by the oxygen, that's going to be a dative covalent bond or a coordinate bond. Okay, so if I draw this out now in kind of the 3rd and final structure, we've got something that looks like this. Okay, remember we show a coordinate bond with an arrow. So that's how we've got. Sorry, I forgot to put the lone pair in here. So we've got, this lone pair of electrons is still hanging around the oxygen there. So we've got 1 lone pair there. We've got 2 single bonds there, and then we've got a dative coordinate bond there. And then we've got our carbon that's got its 2 electrons there. So let's look at these options available. Just remember this is our finished structure. Okay. Which features are present in the CO molecule? 2 lone pairs of electrons. Yes, that's correct. We've got 1, 2 lone pairs. Boom. That's correct. A coordinate dative covalent bond from oxygen to carbon. Yes, it is the oxygen that is giving those 2 electrons there to make that 3rd bond, let's say. So yes, that is correct. And 2 pi bonds. Yes, that is correct. And